let's welcome Hannes Stark, a PhD student with Regina Berzilli and Tommy Yakola at MIT.
So, I guess this slide contains, there we go. Yeah, well, in this work, we're interested in designing proteins that bind small molecules. So somewhat the inverse of the task that we're interested in small molecule drug discovery. And the reason why we're interested in that is, for example, for designing antidotes that sequester small molecules, like toxic small molecules, or for as a first step toward designing enzymes. And the concrete way that we formulate this task is that we're given the backbone of a protein pocket and the 2D molecular graphs of one or multiple small molecules that we want to bind to this ligand, to this protein backbone. And we're not given the 3D structure of the side chains. We're not given the residue types of the side chain, the residue type of the backbone, and we don't have the 3D structure in which the small molecule would bind to the backbone, right? And what we want to generate, what we want to predict are the residue types that would bind the small molecules, and we jointly generate the structure in which the small molecules would bind. And towards that, we first develop harmonic flow, which is a generative process just over molecular structures. And there we use flow matching, which is a generalization of the fusion models with additional design flexibility that we make use of for multiple technical innovations. And here I'm going to highlight two of them. For example, we use a harmonic prior, which is a more informative prior to start a generative process from, instead of just starting from an isotropic Gaussian. And secondly, we, for example, have a structure self-conditioning, which is a general improvement for flow matching models for 3D molecular structures. And then we extend harmonic flow to obtain flow side by including an additional self-conditioned generative process over discrete residue types, and to obtain a very simple and very straightforward, elegant framework for jointly generating discrete and continuous data. So discrete residue types and continuous ligand positions. And for that, we carry out multiple experiments for just harmonic flow, for multi-ligand docking, and for flow site, for binding site design that I'm happy to talk about at the poster session, together with all the other technical innovations that we try to put forward here. See you there.